My name is Noelle Joyner, and it is September 7th, and I am doing my Unit 2 presentation of the mapping demonstration. I apologize in advance that the screen is a little wonky, but my computer broke in the screen display, so I have to do it this way. So to start, we have the data set, and the data set given, there was the three positives here, which is 1340, A, B, C, which is 1,362, the positive, B positive, 400, A positive, positive, 100, A positive, C, 420, C positive C, 970, positive B, C, 140, and A, B positive, 1,010. In this data set, there are 5,742 offspring from a homozygous recessive and either hemizygous or homozygous dominant partner. So, in the organized data set, we have no recombination events with the 1,340 in the all positives, and ABC, which has 1,362, and then we have C crossing over in the positive C with 970, and AB positive with 1,010, and we have the B crossing over with A positive C, which is 420, and positive B positive, which is 400. And then lastly, we have A crossing over at A positive 100, and positive BC 140. So our recombinant and double recombinant cases in this data set, we have A crossing over, which we add 100 and 140, which will equal 240 cases. And the B crossing over has 420 and 400, which results in 820 cases. And then lastly, C crossing over with 970 and 1,010, which is 1,980 cases. The crossing over event that had the least cases is the double recombinant case, and it had A crossing over with a double recombinant, which 240 was the least, 820 in the middle, and then 1,980 at the most. And then B and C crossing over were single recombinants. The order of genes in this, I have a diagram here which shows that the second gene is a double recombinant phenotype, and the order of genes would be B, A, and then C. So the map distance calculations are here. I have the equation as the total cases of B plus double recombinant cases, total double recombinant cases, divided by total offspring of 100. And for distance A to B, it is 420 plus 400, 100, and 140. And you add those together, divided by 5,742. And multiplied by 100, which gives you 18.5 map units. For distance C to A, you'll do same equation, which was 1,010 plus 970 plus 100 plus 140, and then that divided by 5,742,000 times 100, which gave me 38.7 map units. Here I have a diagram of the map of the chromosome and genes. So I put B at the top, A in the middle, and C at the end. And I show the distance between B and A being 18.5 map units, and the distance between A and C being 38.7 map units. And I also have the coefficient of confidence equation breakdown here. I have coefficient of confidence, which C will equal actual double crossover divided by expected double crossover, which was 0.042 divided by 0.0714, and that equaled 0.588. And then I did the expected double crossover, which is, the equation would be probability of B crossing over times probability of C crossing over. So I went ahead and put those values as 0.185 times 0.387, which gave me 0.0714. And then the actual double crossover gave me a equation of total cases of crossover divided by the total cases. And that equation gave me 100 plus 140 divided by 5,742, which gave me 0.042. Lastly, the interference equation, which is I equals 1 minus C, and we had that value showed earlier. So I showed here in my math, I did 1 minus 0.588 to equal I equals 0.412. And because this is a positive value, chromosomal interference is present. And that is the end of my presentation. Thank you, and sorry for the inconvenience of my screen.